We'll continue our lesson with polynomial inequalities. And so we have a polynomial inequality. It is in the proper form. We have everything on the left-hand side greater than 0. We have to factor on the left-hand side to find our boundary points. For terms, we will try grouping. We can take out an x squared. And that leaves us x plus 2. We can take out a minus 4. Remember when it starts with negative. And that leaves us x plus 2. We did get the common binomial, so we'll take that out. X plus 2. And here we have a difference of squares. X squared minus 4. Pick up those pieces, then do your difference as squares. So this gives us negative 2, the same, and positive 2. So we'll show the negative 2 and 2. We want test values that are in each of the 3 regions. So we'll pick a negative 3, we'll pick a 0, and we'll pick a 3. And we have to use our factors. We do have to use the x plus 2 twice. And I'll just scoot it down here. This is the product of them. So multiplying all 3 together. Right, so if we plug negative 3 plus 2 is going to give us negative. Also negative here, negative 3 minus 2 will give us negative. Multiplying 3 negatives is going to give us negative. Right. Plugging in 0. 0 plus 2 gives us positive and positive. 0 minus 2 gives us negative, but multiplying and having one negative, that's odd. That one is also negative. Right? If we try 3. 3 plus 2 is 5. That's positive. 3 plus 2 is 5. That's positive. And 3 minus 2 is also positive. This one is going to be positive. Look back at our inequality, and we want it to be greater than 0. So we want the positive from the bottom line, which means is from 2 to infinity. I'm going to pull up the graphing calculator here and show you what this means as far as a graph. I have typed in the function and we'll say graph. So this is a picture of our graph. It's a cubic, so it looks correct. Here's your double root. And it's going to bounce there, so we can remember those things, right? But for this particular problem, what we want to look at was we wanted the piece that's greater than 0. And so the piece of your graph that you want is this part right here. And notice this is 2, so from 2 to infinity, which matches your algebraic answer. Let's look at another problem. Right, we are in the proper form. Our function is on this side. It's less than 0, so we're good there. We need to try to factor to get our boundary points or critical values. For terms, we'll try grouping again. So we have x squared times x plus 1. We have plus 4 times x plus 1. We have a common binomial. Times x squared plus 4. Now, x squared plus 4 will not continue to factor, and if you try to solve it, it gives you complex answers because you would subtract your 4, x squared equals negative 4, and use your square root method. And so you would have the i's. So we're not going to get a critical value out of this. So the only one we have to look at is negative 1. And we'll still have our pieces. So we have x plus 1. We have x squared plus 4. And we have the product of those. Sorry, my pen is not working good. Right, so something smaller than negative 1, let's try a negative 2, and bigger, we'll try 0. So negative 2. Negative 2 plus 1 is going to give us negative. Negative 2 squared would give us a positive 4, and a positive 4 would give us positive. And the product of these two, a negative times a positive, will give us negative. If we plug in 0, 0 plus 1 is going to be positive. And 0 squared is 0 plus 4 is going to be positive. Positive times positive is going to give us positive. Right? Look at your inequality, and you want the part that is less than 0. So on our number line, the piece we want is here. There is no equals, so it will be parentheses. So it should be from negative infinity to negative 1 with parentheses for your interval notation. Let's have a look at our calculator. I went ahead and typed it in just because it's a little slow to do it on the video. So you would type it in under your y equals. Right? I'm going to click graph. Now this is a cubic. You remember how it should look, like a regular x cubed graph. But this one had some complex things. So two complex solutions, it's not going to cross for those. So it should only cross the x-axis in one place. So let's look at graph. And there we go. It only crosses in one place. That's because we only have one real 0, right? And let's see for our inequality. This time our symbol is less than. So we want the part that is less than 0. And it's this piece of the graph down here. And it is from negative infinity to negative 1, like our algebraic solution. This last problem is just showing us a graph and asking us to interpret, which you should be good at by now. To enter it into your calculator, you would have to get to that proper form. So you would have to subtract 68x and subtract 48 so that you would have greater than or equal to 0 in the proper form. You want that so you can look at pieces of the graph above 0 and pieces of the graph below 0. That's why you need to go to that proper form. So this is the graph of y equals this, and our inequality is greater than or equal to. So we want the parts that are above 0, and this looks like negative 6 to, and they're giving us the coordinates here because it's not on an integer, to negative 2/3. So the parts that are above 0 are from negative 6, and we're going to include that because we have an equals underneath. So negative 6 to negative 2/3. Include that, right? And you have another piece of your graph that is greater than or equal to 0, and that's this piece. And this one is 1, 2, 3, 4 to infinity. Remember, your infinity always gets parentheses. This was our other piece that we wanted. We wanted the parts above 0 because it said greater than or equal to 0. If it had said less than, we would want the parts that were below.